Hello, I welcome you once again into Kenya Mathematics Classroom. On this particular episode, I'm going to help you to be able to prove the almighty formula and how to apply the almighty formula. Now, when we talk about the almighty quadratic formula, the almighty formula, when we say the almighty formula, so we use the almighty formula to solve quadratic equations, and the formula is x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So that is the almighty formula, and use this to solve quadratic equations. Now, I'm going to help you to be able to how to prove. I'm going to help you to prove the almighty formula, where this is coming from. Now, the general form of a quadratic equation is given by a squared plus bx plus c equals 0, where a is not equal to 0. Now, this is the general form of any quadratic equation. It's a squared plus bx plus c equals 0. The a is the coefficient of the square term, the b is the coefficient of the x term, and c is the constant. We are saying that a must not be equal to 0 because it is the square term that determines the quadratic nature of that function. And therefore, if the a equals 0, then a times x squared will be 0. That means the square term is no more. And therefore, it is no more quadratic, but rather linear. But for it to be a quadratic equation, then the coefficient of the square term must not be equal to 0. So the general form of a quadratic equation is a squared plus bx plus c equals 0. So now, this is what we are going to use in proving the almighty formula. So we have a squared plus bx plus c equals 0. So what we do is, the first thing we do is to divide through by the coefficient of the a. Divide through by the coefficient of the a. So dividing through the coefficient of the square term. So we divide this by a, we divide this by a, we divide this by a, we divide this by a. That is, we are dividing through by the coefficient of the square term. And the coefficient of the square term is a. So we divide through by a. Now, this by a will give us x squared because the a will be gone. Then we have bx over a here. Then we have plus c over a here. Don't forget that 0 over a will still be 0. Then when we are done with this, we now take the constant to the other side. Now, when we take plus c over a to the other side, we minus c over a, or we can say that subtracting c over a from both sides. So this is what we are talking about. We have x squared here plus bx over a here plus c over a. So we subtract c over a from the left hand side. Then we do the same thing to the right hand side. And when we do that, we have not changed the equation. So c over a minus c over a will give us 0. So on the left, we now have x squared plus bx over a is equal to 0 minus this will be minus c over a. Minus c over a. So what we do now is we take half of the coefficient of the x. Take note that the coefficient of the x now, the x term is now b over a. So when you say take half of it, then half of b over a will now be equal to 1 times b is b, 2 times a is 2a. So half of the coefficient of the x will now be b over 2a. So we add it to both sides. So in doing that, we are going to have x squared plus bx over a plus the b over 2a. We add the square to the left hand side. Take note that whatever we do to the right hand side, we must do the same thing to the whatever we do to the left hand side, we must do the same to the left hand side. So we also add the square, that is b over 2a squared. And this does not change the equation. So what is really happening here? We took half of the coefficient of x, and half of b over a is b over 2a. Then we add the square of the result to the left hand side and to the right hand side. And so this is what we are getting. Now, by completing the squares on the left hand side, here we have x squared here. This is x squared. So we have x squared here. Then we have b over 2a also square here. So we look at the squares. Now, we have x here plus, in the bracket, we have b over 2a. They are all square, so we square it. And this is equal to, we have minus c over a here plus, according to indices, the 2 is affecting both the b and the 2a. So this will be b squared over 2 squared will give us 4. Then we have a squared. So take note that when you simplify, that is x plus b over 2a all squared. This will give you the same expression here. We have not changed it. You can take your time and expand this. Now, when we say x plus b over 2a all square, it means that we are multiplying x plus b over 2a by itself. So if you multiply x plus b over 2a by itself, you realize that you are getting the whole of this expression. So this is not left out. Take note, this has not been left out. It is still inside of this. It is still inside of this. So x plus b over 2a all square is the same as what the whole expression we have here. By completing the squares, we took the x plus what is in the bracket. That's x plus b over 2a. And because they are all square, then we square it. And when you expand this, you will get this back. Later, when I'm done with the proof of the formula, I will expand this so that you understand what I'm talking about here. So now a step down, then we have x plus b over 2a all square. This is the same as the b square can come first. That's b square over 4a square. Then you have your minus c over a. It's the same size, so no sign will change. It's the same thing, this here and this there. Now, we now take the square root of both sides. We can now take the square root of both sides. So take note that, or we can simplify the right. It depends on how you want to do it. But now look at what is happening. So we have x plus b over 2a all square. Let's try to find the LCM first. And the LCM will now be 4a. Will now be 4a. So it will be 4a square. So this here, 4a square. Then we have 4a square times b. So that's b square over 4a square. Then we have minus c over a. So the LCM is 4a square. So this here 1. This goes here 1. And 1 times b square will give us b square minus. Then a takes one of the a here. Then we are left with 4a. So 4a will multiply c. And that will give us 4ac. So we now, if you have x plus b over 3 all square is equal to b square minus 4ac all over 4a square. Take note that if you have x square equals 4 and you are trying to solve for x, you now take the square root of both sides. And when you take the square root of x square, you are left with the x here, but the square root of 4 here will give you 2. So we are trying to make x the subject. That means you have to take the square root of both sides. So when we take the square root of the left-hand side, when we take the square root of the left-hand side, we also take the square root of the right-hand side. And this is gone. So we have x plus b over 2a. And this is equal to, when you are taking the square root of anything, it is plus or minus the answer. Now, this will be the square root of b square minus 4ac all divided by 2a. Why is it 2a? It is 2a because you see that it is now out of the square root sign. Here, 4a square was in there, but the square root of 4 is 2. And the square root of a square is a. So when you write 2a, then it should be out of the square root. Now, this is what we have here. So we have x here is equal to, because you are solving for x, then this should have to be on the right-hand side. So plus b over 2a will now be minus b over 2a. Then we have plus or minus, we have the square root of b square minus 4ac all divided by 2a. All divided by 2a. So if you look at this, a step down, if you simplify, you can find the least common denominator. The 2a will now be, this 2a here, 2a here. So in all, that's why, how come you have the 2a here? That is all. So if you find the LCM or the least common denominator, then you are going to have, let me get this off. You will come back to the same formula so you understand what is really happening. So if you have x here is equal to, you are trying to find the least common denominator, and that will be 2a. So 2a here, 1. Then 1 times minus b will give you minus b. You have to plus the minus here. Then 2a here, 1. Then 1 times everything there will be the square root of b squared minus 4ac. So this is what we call the this is what we call the almighty formula, and that is the proof of the almighty formula. That is the proof of the almighty formula. So I want to go over this again. Now, you saw that the general formula for quadratic equation is ax squared plus bx plus c equals 0. So you first divide through by the coefficient of the square term. So divide by a, divide by a, divide by a, divide by a. And this is gone. We have x here, then bx over a here, then you have c over a here, then 0 over a is 0. So we have, now we subtract c over a, that's the constant from both sides. So we have x squared plus bs over a plus c over a. We subtract c over a from the left, then we subtract c over a from the right. Then in doing that, this is gone. Then we have x plus b over a equals minus c over a, because 0 minus c over a is minus c over a. Then from here, we take half of the coefficient of the x, and the coefficient of the x is b over a. So half of b over a is b over 2a. Then we add the square of it to both sides. So the square of b over 2a is added to the left-hand side. That's how come we have this. And it is added to the right-hand side. That's how come we have this. Then we complete the square. So we have s square here. Then we have b over 2a also square here. So by completing the squares, we are not ignoring this. But when you write x plus b over 2a all square, when we expand this, you come back to this. And this will be equal to minus c over a plus b square over 2 square is 4, then a square. So we have 4a square. And when you get here, you can bring the b square over 4a square first, then you take this there. No sign will change because we are still on the right-hand side. So we have b square over 4a square minus c over a. Now, if you have x plus b over 2a, we are trying to make x the subject. So we have to do away with the square by taking the square root of both sides so that the 2 will be gone. The square root of the right-hand side. So we have x plus b over a equals plus or minus the square root of anything. So if you are taking the square root of something, it's plus or minus the answer. So it's plus or minus the square root of everything. Now, what happened here was we have to find the least common denominator. That was 4a squared. So 4a squared goes in here once. Then 1 times b squared will give you b squared minus this takes one of the a and we are left with 4a. So 4a times c will give us the 4ac. And so when we take the square root of both sides, we have the square root of the numerator b squared minus 4ac all divided by the square root of 4 here is 2, but the square root of a squared here is a. That's how come the 2a is now out of the square root sign. Then we have s equals, we take the plus b over 2a to the right-hand side, and that becomes minus b over 2a, plus or minus the square root of b squared minus 4ac, all divided by 2a. So here we find the least common denominator, that is 2a. And 2a here, once. Then 1 times minus b is minus b, plus or minus. Then 2a here, 2 goes in here once. And 1 times everything up here will be the root of b squared minus 4ac. So this is the almighty formula. This is the almighty formula. And let's look at how best we can apply. What do we use this for? We use the almighty formula to solve quadratic equations. So let's assume that we are given x squared minus 5x plus 6 equals 0. This is a quadratic equation. The coefficient of the square term a is 1. Coefficient of the x term is minus 5. And the constant c equals 6. So using the almighty formula, wherever you see a, you now substitute that by 1. Wherever you see b, you substitute that by minus 5. And wherever you see c, you substitute that by 6. So in doing that, x will now be equal to minus b. Minus, b is minus 5 from the question. Plus or minus the square root of b squared. So it's minus 5 squared. Minus 4ac. Minus 4a is 1. C is 6. All divided by 2a. 2 and a is 1. So we simplify this. We have minus 1 times minus 5 will give us plus 5. Plus or minus the root of minus 5 squared is 25 minus 4 times 1 times 6 is 24. All divided by 2. So x will be equal to 5 plus or minus. Now take note. This 25 minus 24, that is 1. Square root of 1 is 1. Divided by, all divided by 2. So we have two answers now. We have two answers now. The first one, first value of x is when we are using the plus. So it is 5 plus 1, which is 6, divided by 2. And that will give us 3. And the second value of x is when we use the minus. So 5 minus 1, which is 4. 4 divided by 2 also give us 2. So these are the values of x for which the quadratic equation is equal to 0. So when we have to solve the quadratic equation, this is how we use the almighty formula to solve for that. So that is the proof of the almighty formula, and that is how we apply the almighty formula to solve for quadratic equations. Now, if we are trying to solve this quadratically without using the almighty formula, I guess you can also do that. You can refer to my presentations on quadratic equation, you will get it better. So if you have x squared minus 5x plus 6 equals 0, what you do is you multiply coefficient of the square term by the constant. So the coefficient of the square term here is 1. But 1x is the same thing. 1x squared is the same as x squared. So the 1 times 6 will give us 6. Then you keep the 6 at the back of your mind. Search for two numbers. When you multiply, you get a 6. But when you add, you get the coefficient of the x. That's minus 5. So here you are going to have x. The numbers are minus 3 minus 2. So x squared minus 3x minus 2x plus 6 is equal to 0. Do you know why it's minus 3 minus 2? Because minus 3 times minus 2 will give us positive 6. But minus 3 plus minus 2 give us minus 5. So that is what you do. Then you factor x out here. You have x minus 3 in here. You factor minus 2 out here, you have x minus 3, all equals 0. So check those terms you have outside. You have x here, then you have minus 2 here. You keep it in one bracket. The brackets are the same, so you maintain 1. And this equals 0. I guess you understand this. If you don't understand this, you refer to my video or presentation on quadratic equations so that you can get it better. Now we have x minus 2 is equal to 0. That means x is equal to 2. If you have x minus 3 is equal to 0. Solving for x, you take the minus 3 to the left, to the right hand side, and the minus 3 becomes plus 3 on the right hand side. So we have x equals 3. It's either this, or we can say that adding 3 to both sides. And when you add 3 to the left hand side, minus 3 plus 3 is gone. You are left with only x, and 0 plus 3 will be 3. That's how come we have the 3. So that's what you do. So when we say minus 3 becomes plus 3 on the right hand side, that's the meaning. We are adding 3 to both sides. And here we are adding 2 to both sides. So minus 2 plus 2 is x on the left, then 0 plus 2 is 2 on the right. So we see that we are getting the same value. So that's how we use the quadratic formula or the almighty formula to solve quadratic equations. So in general, that will be all for now on this particular episode. Thank you.